We're trying to map the entire universe, and that's a pretty big job to do. We're expecting this survey to pick up about 70 million galaxies. We're not planning to look at 70 million galaxies one by one. Instead, we need to use machine learning so that the computers will look at them and tell us which the interesting ones are, how many there are of what kind, and so on. And this turns out to be a hard problem. There's a lot of work that's been done on how to get computers to see, and even more work is being done on trying to get computers not just to see, but to assign meaning. And so we're trying to do that in astronomy, which is in some ways an easier problem than a cluttered city street, and in some ways is a harder problem. All of these new techniques that we're trying to understand and work with are widely applicable in a lot of different places. And this is a general thing that we find in the basic sciences, is that when you take a bunch of motivated, bright people and you give them a really hard problem to solve, they tend to come up with some pretty interesting things. And sometimes we're able to take some of those interesting things and use them to understand the universe, and sometimes our drive to understand the universe is actually what makes us invent the new and interesting things, which then go on to change the world. It's important for people to be connected with science, partly because it shapes their world. Our world is completely shaped by science and technology, but it also is how to understand our world. We don't just manipulate our world with it, we understand our world with it. We understand even what effect we're having using science. But even the things that are outside our own environment, science helps us to understand not just what is there, but how it works and why it works. So we're not just looking at a pretty light show. We're trying to understand, why does it do this? And that curiosity, that real drive to understand how and why, seems to be a tremendously human thing.